Yeah, so we're on our second presentation for the day, Ceph RBD performance with a queue depth of 1 and a block size of 4K. And Wido is nice enough to go ahead and give us a nice lightning talk presentation here. So Wido, will you please take it away?
Yeah, sure. I'll keep it brief because indeed is a lightning talk talking about RBD performance with a queue depth of 1 and a block size of 4K. And so you might be asking yourself, why queue depth of 1 and 4K block size? Well, what I would say is that, from my experience, is that single-thread I/O latency is very important for many applications. What we do see with benchmarks is people focus on high amounts of bandwidth or large amounts of IOPS, but they simply go multi-threaded with a high queue depth, and then they can say, well, we reach 1 million IOPS with Ceph, or we reach 2 million IOPS. But in the end, if you look at the latency of a single I/O, it could be pretty high. And for example, a PHP web server or a MariaDB database or a Redis cache, when it's flushing to its disk, they're all doing single-threaded I/O, and then the latency of that single-threaded I/O starts to matter. And that's what you notice. It's how snappy applications feel. It's by using a queue depth of 1. So all the benchmarking I do with Ceph, almost always I start with queue depth of 1, block size 4K. Then that's my starting point. And from there I start increasing the queue depth, increasing the block size, and then we get more information about the performance of the cluster. But it all starts with a queue depth of 1 and a block size of 4K. So low latency Ceph. Well, you should understand that Ceph itself will never provide you the lowest latency possible. That's because Ceph was designed for other things than latency. It was designed for redundancy, scalability, and data safety. If you take a local NVMe and put it in your laptop or your server, it will get a way better latency than Ceph will ever provide you, because we need to go over the network, over TCP/IP, then it goes through the CPU, then the CPU is doing its thing, then the code, of course, which runs in the CPU of Ceph does its thing, and then it writes to 3 nodes. So keep in mind, we're replicating usually 2 or 3 times, and then that simply takes time. So writing a block in Ceph will be slower than different types of storage. However, redundancy, scalability, and data safety. And I always say I have never seen Ceph lose data because Ceph itself is always something else which happened, lots of hardware failing, but Ceph itself just cares about your data. And safety is the second or the third priority. Performance is the second or third priority for Ceph. Safety is the number 1 priority. So, but what can we achieve? What can we get out of Ceph in terms of IOPS? So I do benchmarking with FIO. Super simple configuration. We take the IO engine RBD, then we use the pool RBD. I have an image there called FIO1. Make sure you run these tests multiple times, because you need to pre-populate the RBD image by running the test a couple of times, and then you simply say, I have an IO depth of 1, block size of 4K, and I run the test, and then after 60 seconds it tells me how fast or how low the latency is of the Ceph system. So some hardware setup. I took some Supermicro systems with an AMD EPYC 16-core CPU, 256 gigabytes of memory, 4 Samsung PM SSDs, and then the 100 gigabit networking with Mellanox. Now, a few things to mention here is that the main performance gains you're going to get is pinning your CPU C state to 1. That's a kernel parameter. You look it up on Google, you can find how you can tune it and set the performance profile of the CPUs to performance. So that means that the CPU will run on its maximum gigahertz as it can run. I think in this case it's 2.4 gigahertz, but then you get the lowest latency from the code possible. 100 gig networking doesn't matter. I had 100 gig here, so that's what we use, but the amount of bandwidth which we're using for this test is a few megabytes per second. It's not gigabits per second. So 25 gig networking works, 10 works. 10 is slightly slower, but keep this in mind, it's very slightly slower. Most of the time Ceph spends in the CPU where the code is running, so the C state pinning and the profiling of the CPU matters that much. Software-wise, Ubuntu 18.04, Ceph version 15.2.8, and then I turned off all the logging. So debug_OSD equals 1, debug_MS for messaging equals 0, etc., etc., etc. Turn off all the logging, and then we can give it a go. So what can we achieve? 1364 IOPS, which I was able to get with this hardware. So that's a write latency of 0.73 milliseconds for a 4K block being written to 3 nodes at the same time. So this includes all the replication. The block which we just written has been written to 3 different NVMEs in different nodes within 1 millisecond. That's what we were able to achieve. And that's a fairly good performance if you look from the perspective where Ceph comes from. We replicate over the network. It's a distributed file system which can scale out, and we still get a very decent performance. Do we want more? Yes, always. So, well, what can the future bring us? The Ceph Crimson project for redesigning the OSD should provide us better latency, although Crimson itself is not focused at the moment at providing lower latency. They're just revisiting the code. In the future, it should provide lower latency. And then we have the RBD persistent write-back cache, which uses a local NVMe inside a hypervisor to cache IOs. I tested this with 16.2.4. But it was not stable enough to provide real results which I could present here during this lightning talk. I did see about a performance increase of about 2x, so 3500 IOPS with a much better write latency. However, that's what I saw for now. I'll revisit this in a later stage when the code is more stable, but at the moment we need to do is with the 1364 IOPS, which we're able to achieve. So if you want to get to this, faster CPUs, higher clock CPUs gain you more benefit in terms of latency than more cores. So if you need to invest, go for higher clock CPUs with less cores. So if I go back to the hardware, the reason this one I chose for a 16 core because this specific Supermicro system can have 10 NVMEs, so we have 16 cores on 10 NVMEs. You could also say if there was a CPU with 10 cores, there's none with 8 cores, maybe you can go with 8 cores and even higher clock CPUs. That will bring down the latency. It will not bring down, give you more total I/O for the whole cluster because that still relies on the amount of cores. So it's a balance. If you're looking for lower latency, you need faster CPUs. If you need more total amount of I/O for the system, then you need more CPU cores in the whole cluster. And that was my lightning talk about Ceph with low latency RBD. And if you have any questions, this is where you can find me or ask them on the users or dev mailing list because that's where I'll hang out as well.
We got 4 minutes. So if anybody wants to ask questions on the spot right now.
More than happy to answer them.
I have a quick question. Was the RBD cache enabled in this?
No, RBD cache was not enabled because if you look at the RBD cache code, it's right through until flush. So only if a client sends a flush towards librd, it enables the cache. And if we go back to the FIO configuration, it says a direct equals 1. So that means it's not sending any flushes. So all the I/O is synchronous, which is being sent by FIO. So no, the RBD cache is not enabled. I turned this setting. It's called RBD underscore right through underscore flush. If you set that to false, then it always goes into an RBD cache and turned on. And then I think I saw about 10 to 20,000 IOPS. But yeah, then we're just writing stuff into memory of the RBD cache.
Cool, thanks.
I have a question. This is Dan. Well, it might be for Ilya if Ilya is still online. But yesterday, Ilya presented. He mentioned some IOPS improvements on librd, maybe in Quincy. I'm not sure exactly when they're coming. But Ilya, are they going to also improve QDepth1 performance? Or maybe Wido, you know?
Well, I doubt it because I also did benchmarking with the Rados client. So Rados, and then if you set Rados bench, but if you set -t, so the amount of threads to 1, then you can write blocks of 4K directly to Rados. And the latency I see with QDepth1, so with a single thread on Rados, is about the same as I see with RBD. So I do doubt if this improvement of librd will lower the latency because I do think we're bound by the OSDs and by TCP/IP in general, not by librd.
Okay.
Yeah, I agree. Probably not for this test because those improvements mostly, cut the fat that we had between librd. Some of it was in Librados, mostly in librd, because the fat that is in librators kind of sort of still there. And where what those improvements were targeted at is really the all NVMe clusters and fairly high Q depth. So probably not for this test. One thing I want to note as far as FIO and flushing, recent versions of FIO have actually been modified. The RBD engine within FIO will now issue a flush in the beginning of any test just to deal with that setting. So in the future, you might need a way to, if you want to test without RBD cache enabled, you would need to turn it off in the ceph.conf or elsewhere, because FIO will issue that single flush at the beginning of the test just to tweak that, just to move librd into the state where it thinks that the client sends flushes, and so it will do caching by default.
Okay, that's good feedback indeed, because that will, give different results, and people might have the idea that they're able to do 20 to 30,000 IOPS with their FIO, but actually it's all cache of librd. So, are you sure that with direct equals 1 that it will still send the flushes?
I think so. This was we did this to address the discrepancy between FIO and RBD bench command, because RBD bench has been doing this, has behaved this way, where it would possibly send the flush in the beginning of any benchmark for many years now, and FIO wasn't doing this, and we were getting complaints that here are my RBD bench results and here are my FIO results, and they're vastly different. And so at least the intent of the change was to do it even with direct. But I wasn't involved, so I'm not sure. It's just something I wanted to bring up.
Okay, cool. That's good feedback. Any other questions or comments? Thank you. Yeah, so just as a closing note, I always test, as I said, with the Q depth of 1, because that tells me the latency. And I think that latency is the foundation for most applications, their performance. So I always try to test with that.
All right. Thanks, Wido, for the lightning talk. Appreciate it.
You're welcome.
Got some good questions in.